Hi, Princeton Tigers. All right, so during our video lesson, we're going to be reviewing scientific notation, which we started on Friday. If you weren't here for it, don't worry about it. We'll be doing it all over again today. So scientific notation is a way of expressing really big and really small numbers. So really big and really small numbers can be expressed in scientific notation. Fill that in the first two blanks on your page. Our two rules for scientific notation, and you can pause the video right here and copy these down. Number one, our first number, this little hashtag means number, is 1 through 9. So it needs to be between 1 and 9. Our second rule is that we need to multiply that number by 10 raised to an exponent. Pause the video right here, copy these rules down. At the bottom here, I have examples, which I'm actually going to erase this and make it bigger, so last chance to pause the video. And so my examples are 4 2/10 times 10 to the 5th. This is written in scientific notation. Our front number is between 1 and 9, and our second number is 10 raised to an exponent. This is equal to 420,000. So is this a really big number or a really small number? Right, it's a really big number. So this helps us shorten the way that we can write it. For the next one, I have 6 times 10 to the negative 5th, which equals 0.00006. Is this a really big number or a really small number? Right, it's really small. So this scientific notation is helping us write a really small number. Is our front number between 1 and 9? Yeah, and our second number is 10 raised to an exponent. Looking at question 1, and let's look at these two examples. When the exponent is positive on our 10, is the number really big or really small? So let's look here. Which of these exponents is positive, the first one or the second one? Yeah, my first one, my 5 is positive. And is our number really big or really small? Really big, because that means that we're multiplying 4 2/10 times 10,000. 10 to the 5th power, 100,000 is 100,000. You can do that out on your calculator and you'll get that. 10 to the 5th power is 100,000. So if we're multiplying this number by 100,000, it's really, really big. So answer question 1. When the exponent is positive, is the number really big or really small, and why? Now question 2. When the exponent is negative, is the number really big or really small? And which one of these is our exponent negative? Right, and the second one. And does our number end up really big or really small? This is a really, really, really tiny number. This is just a very, very small fraction, or a very small decimal. So our number is really small. Why is our number really small? Because negative exponents mean division or fraction. So we're dividing 6 by 100,000. And we're getting this tiny, tiny, tiny number. All right. So make sure you have answered question 1 and question 2. And now we'll go on to the example problems. All right. So what you're doing in these problems is you're placing the decimal so that the number becomes between 1 and 9. So where can I place my decimal in this number so that my number is between 1 and 9? If I place it where this comma is right here, my front number is 620. Is 620 between 1 and 9? No. What if I place it after this right here? Now it's 62 instead of 620. But is 62 between 1 and 9? No. So I'm going to keep trying to make it smaller. So now I have 6 2/10. Is 6.2 between 1 and 9? Yes, it is. So the decimal goes between the 6 and the 2. How many times did I have to move the decimal? So when I start with a whole number like this, my decimal is always at the end. And now it's here. So we need to count how many times we moved the decimal. And it's 1, 2, 3, 4, 5 times. So place the decimal between the 6 and the 2. You moved it 5 times. Is this a really big number or a really small number? Right, it's really big. So those are your answers to the 3 questions. Let's try another example because I know this is new stuff. All right. For the next one, we have 0.3054. First, we need to place the decimal so this number comes between 1 and 9. Right where it is, we have a really small number. If I place it here, that's still a small number. That's just 54 thousandths. If I place it here, we have 0.54. That's still small because our numbers are after the decimal. What about if I place it here, though? Now I have 5.4 or 5 and 4 tenths. Is that between 1 and 9? Yes, it is. So my decimal needs to go here. My decimal started here, so how many times did it move to get there? 1, 2, 3, 4. So I needed to move it 4 times. That's your answer to the next question. And lastly, is this number really big or really small? It's really small. Let's go on to do 2 more. For my next number, I have 52,100. Where do I need to place my decimal so the number becomes between 1 and 9? If I place it where this comma is, I have 52.1. Is that number between 1 and 9? No. If I move it back, now I have 521. Is that between 1 and 9? No. I need to place it right after that 5 because now I have 5 and 21 hundredths, but it's a little bigger than 5, so is that between 1 and 9? Yes. Where did my decimal start out? Because it was a whole number, my decimal started at the end. So how many times did it move to get there? 1, 2, 3, 4. So it moved 4 times. And was this number really big or really small? It was really big. So those are your answers to those questions. Next, I have 0.0312. So I need to figure out again, where do I place the decimal so that the front number comes between 1 and 9. Where it's placed right now, our number is way too small. If I move it here over once, I have 0.312. Is that still too small? Yep. If I keep going and move it here, now I have 3.12. These zeros in the front don't matter. So now is that between 1 and 9? Yeah. How many times did I have to move it to get there? 2 times. And this number is really small. I know this is new stuff, and so you might not completely understand it, but we'll be going over it together. All right. Good luck finishing up this worksheet, and I'll see you at the end of class.